Students, welcome back everyone. In this section, we are going to learn one of the most important concepts in engineering mechanics called the free body diagram or simply FBD. A free body diagram is a simple sketch that shows an object separated from its surroundings along with all the forces acting on it and their directions. When drawing an FBD, we remove all the supports or contacts and replace them with their corresponding reaction forces. This helps us focus only on the forces acting on the particular object. By using a free body diagram, complex engineering problems become much easier to understand and solve the particular problems. You can see in this example that the block on the inclined plane is subjected to four forces: the applied forces, the friction forces, normal reaction, and the weight of the object. These are the forces that we need to consider while analyzing the motion or equilibrium of the body. So now let us understand another important concept called the equilibrium force. An equilibrium forces is the force that brings a body into mechanical equilibrium. In simple words, if several forces are acting on a body produce a resultant force, that the equilibrium force will have the same magnitude as the resultant but will acting in the opposite direction. The resultant force tends to move the body, whereas the equilibrium force keeps the body in static state of rest or equilibrium. For example, when load is hanging from a rope, the tension in the rope acts as an equilibrium force to balance the weight of the body or load. So, a free body diagram is a graphical representation of all the forces that act on a certain body isolated from its surroundings by replacing the constraints. That means the replacing the any other surroundings. Therefore, drawing a correct free body diagram is always the first step in solving engineering mechanics problems. Let us understand the concept of a free body diagram using these examples. When we isolate the boat from the surface, we replace the contact with the force acting on the boat. The first force is the weight, which acts vertically downward due to gravity. The second force is the normal reaction, which acts perpendicular to the inclined surface. The third force is a frictional force, which opposes the motion of the boat along the surface. Instead of drawing the complete inclined plane, we only represent these forces acting on the isolated object. This simplified representation is called the free body diagram. So we have a lot of procedures that the procedures should draw a free body diagram of a particular particle. The first step is to identify the object that we want to analyze. Instead of drawing the complete object, we represent it as a simple dot or point. The second step is to identify every external force acting on the object. These forces may include weight, applied force, tensions, frictional, normal reaction, or any other external force. Let us understand the procedure with a simple example. Here a box is hanging from a wire. The first step is to isolate the box and represent it as a single point. Next, identify the force acting on the box. The weight of the box acts vertically downward and it's represented as a equal F. The wire exerts and upward tension forces on the box. These two forces together form the free body diagram. If the box is at rest, the upward tension is equal to the downward weight and the body remains in equilibrium. Thank you.